Good morning, Dr. Mikhail. This is the part of the semester, I guess you guys are getting a lot of exams, right? You have enough material covered, so first round of assessment, how's that going? Going all right? Super. The weather's been great, isn't it? This week 4 in Loretto, and it's still been gorgeous, so you cannot complain. We have this beautiful facility. By the way, there is a ribbon cutting for this facility on Friday at 4 o'clock. If you're not doing anything, it'd be great to have some student support. There's going to be refreshments. I don't know, that's probably like punch, you know, not the good kind of refreshments, but anyways, if you can show up, you know, that'd be great. I don't know if we have any giveaways planned. Maybe I'll give you that. But anyways, okay. So what we're going to do today is a couple things. We will go over the homework on histograms, and we're going to kind of close out chapter 2. Okay, there's another kind of PowerPoint slide. We're going to talk about graphical deception, and we do need to have an exam. So we can talk about when that exam will be. The two possibilities are Thursday, which is 2 days from today, and Tuesday, which is a week from today. So we can talk about that when I talk about the format of the exam. So what we are working on, as I recall from the homework, is we were talking about histograms. And histograms are a way of showing what interval data looks like. And because it's interval data, we have to kind of group it first so that we can display it in a histogram, which is kind of a sister to the bar chart. And I'd like to do at least one of these. So I assigned, I can't remember, like 6, 16, and 18, were those the 3 I assigned you guys? So let's look at those. Is there one in particular you would like to do? If not, we will do, I'll just pick one. Is there one in particular you guys would like to do? All right, let's take a look. See if there's an interesting one. All right, let's look at 18. Okay, 18 is as good a business example as any. 18 says, this is on page 33, it says, the length of time in minutes to serve 420 customers at a local restaurant were recorded. How many bins should a histogram of these data contain? Draw a histogram. So let's go get the data first. So I'm going to go to book Excel files, course text Excel files by chapter, chapter 2, and we're going to go to XR02-18. So I'm going to bring up that data and close that. I will upconvert that data, and yes, I want to do that. And here's our data. So we see it starts in A1, that's a label. And if we go to Control End, we see it ends in 421. So yes, indeed, we do have 420 data observations. So the first thing I want to do is I want to find the range of the data. Like, what's the spread? Like, what's the fastest someone ate and what's the longest it took someone to eat? So how do I do that? There's a couple ways I could do that. Give me one way. Give me one way. Rachel? Oh. All right, so I'm going to click on column A. I'm going to go to sort and filter. Sort smallest to largest. It looks like the smallest is 28. Sort largest to smallest. It looks like the biggest is 92. So I'm just going to come over here and I'm going to put the maximum is 92 and the minimum is 28. So the spread of that data, the range of that data, is going to be F2 minus F3. So 64 is the spread, the range of it, right? So I want to, and how else could I have done that? There's another way I can do that. What else could I have done, Evan? So I could have said equal min, A2 to A421, and that should also go through there and find 28. And I could do equal max A2 to A421. Whoops. And that will give me 92. Okay, so the range is 64. Now, that's the range we need to cover. We need to figure out, how many classes we should have. And like I said, I will give you this. I don't have it memorized myself. So I will give you this table, but it's in your book, and it's also in the slides, and it's on page 21 in your book. And it looks like this. It says, based on the number of observations I have, about how many classes should I have? So I have 420 observations. So according to this, I should have what? Approximately what? How big should my classes, or I'm sorry, how many classes should I have? 9 to 10, okay? So let's take a look at what that comes out to be. So I'm going to say that range, I'll say 9 and 10 here. If I take that range, which is 64, which is an F4 for me, and divide it by H4, it comes up to every 7.11. I don't need to use Excel for that. That's going to come up to 6.4. Okay. So those are kind of a rule of thumb. They're saying our classes should be about 7 or about 6.4, about 7.11. But I don't want to use either of those. I don't want to use either of those. What did you use? Leah, what did you use? You used 10, so that's fine. You use every 10. You probably have about 6 classes, right? Okay, so probably a little less than they recommend, but if it looks right, it looks right. Anyone else? Anyone else? So we used class size of 10. Anyone else? Daniel? 8. Okay, so that's fine. Anyone else? I think what I would do, let's do it with. I really don't like going by 7s and 8s, and as much as possible, if it's an option, I like to go by 5s and 10s, right? So 10 would be okay, but I want more classes rather than less classes. So I'm going to go every 5. So I'm going to say 5, 10, 15. And you might say, well, Dr. Mika, we don't have any data until 28, so why are you putting down 5, 10, 15? I'll figure that out later, right? I'm just going to go 5, 10, 15, and then I'm going to highlight that. And remember, Excel recognizes patterns. So if I drag down, it says, hey, it looks like you're adding by every 5, and yeah, I am. So I need to stop, when I get to, 95 will cover because the highest one is 92. Okay, so I build those, and you're saying there's not going to be any data in those first ones. Yeah, I know, but I'll fix that later. All right, you guys with me? Now we need to use a tool that does this for me. So I'm going to go to Data. Okay, it looks like it turned off on me, so I got to turn that back on. I don't know why it turned off. Options, add-ins, go. I got to recheck. Maybe this thing resets because it's a laptop, but yours probably didn't reset, right? So you had data analysis, and now I do again. And I'm going to go to histogram. My input range is A1 through A421. My bin range, or my class range, is going to be from B1 down to B20 in my case. And I need to check the labels box because that tells Excel, hey, that first row isn't really data, it is labels. So I check that box. That's the input. I want a new worksheet ply, put this in a new worksheet ply, and I want chart output. So I click OK, and I come over here, and it builds the start of a histogram for me. Okay, it builds the start of a histogram for me. Now a couple things. Okay, we all know that our histogram should not have gaps. So I'm going to go to Design. I'm going to go to Quick Layout. It looks like the 8th one has no gaps. If I want to make it better, I'm going to have to do a Quick Layout again. It's a better, so I would obviously want to change the titles here, right? Histogram's an awful title. Oh, by the way, I graded your in-class Excel assignment. Hope you guys saw the results of that, yes? Generally pretty good. I thought you guys did pretty well. The only issues were titling, vagueness, pie chart. Maybe the pie chart should have percentages, right? Pie chart is a percentage thing, so that was kind of an issue, but overall pretty good. Couple things. I want to get rid of more, and I probably want to get rid of all these blank classes. I don't have to, but I'm going to get rid of more. How do I get rid of more? Well, this table is tied to this chart, so if I right-click on 21 and delete, I delete it from the table. I also delete it from the chart, and the ones with none in, let's get rid of them while we're at it. I'm going to delete those. And I have something that looks like this. Now I would like you to interpret this histogram for me, because creating the histogram is great, but we also want to interpret it, right? You'll know in your take-home assignment, and even in the in-class assignment, I asked you to interpret things, yes? So interpret this for me. What do you think? What are the things we want to analyze with a histogram? Jonathan?
I'm not sure.
Give me something, Josh. Come on. Explain the shape to me, Jonathan. Is it?
It's not equal on both sides. Like it's not
Symmetrical.
symmetrical.
Okay, it's not perfectly symmetrical, right?
Right.
But remember, it doesn't have to be perfectly symmetrical. Like I'm not perfectly symmetrical, right? I told you about my freehism, right? You guys know that. And what do you think about the modality of this thing? Where are most of the observations? It's not a perfect, unimodal, but where are most of the observations? Yes? Mark? Where's the big classes, Mark? They're in the middle, right? They're in the middle, right? So what do you think? It's kind of symmetrical. The big classes are in the middle. On the ends, there's not many. I can almost envision, it's not perfect. It's not going to be perfect. But Tony, what do I have here? I would say it's close. It's not perfect, but it's very close to the normal distribution. Remember, the normal distribution is what shape? What shape is it? What is another name for that? The bell-shaped distribution. What follows the bell-shaped distribution? Many things, right? Many things that occur in nature, like the height of humans, right? The IQ of humans. And think about this, we're measuring how long it takes people to eat at a restaurant. Well, there's always a whole bunch that are around the same time, right? It's a standard kind of deal, right? It's this water in the middle. A lot of things happen like this. And there's some that take 95 minutes for whatever reason. They're lounging over the coffee and there's people in a hurry to get the hell out of there, right? But not as many of them as the ones in the 50 to 60 minute range. So I would say that this is nearly bell-shaped, nearly normally distributed. It's not perfect, and it's never going to be perfect. Well, sometimes if you take 1 million observations, something, it turns out it's damn near perfect. But when we only have 420 observations, but I can definitely see that occurring here, right? If we took the heights of babies that are born or the weights of babies. So how is this information used? Why do we care that it's normally distributed? Why do we care that things are normally distributed? Come on. So when you were a child, when you were a baby, let's talk about medical. Let's talk about you as a baby. Your parents took you to the doctors for your wellness check 3 months, and they measured you and they weighed you and they also took your head circumference, right? And then in 2 years they did that, in 3 years they did that, in 4 years they did that. And Evan, what did they come back with? They said that you were maybe, Evan, you're probably a big baby, right? You're probably a big, you were probably in the 99th percentile, right? Do you remember that? Yeah, your parents are probably really proud of 99th percentile. Why do they do that? Just so that your mom and dad can brag? Why do they do that? Why do they do that? Okay, they know that most humans are in this range, right? And they look for like outliers. If the baby's head is not big enough, or not the baby doesn't weigh enough, right? Or maybe it's too damn big, whatever it might be. They look for outlier situations, yes? And in the business world, we look for outliers all the time. I was in charge of, when I was with M&T Bank, I worked for them during September 11th, right? And after September 11th, the United States government passed something called the Patriot Act, if you ever heard of the Patriot Act. And basically what it meant was, for banks, we had to spy on our customers more, right? We had to look for things that were suspicious. And we can't look at, the M&T Bank, where I work for, does millions of transactions a day. We can't look at every transaction. So we looked for the outlier transactions. We looked for, obviously, wires to Afghanistan were important, right? Those kind of things. But we also look for, hey, things that are several standard deviations outside this person's normal, right? Bill Gates, a $100,000 transaction is normal. For me, a $100,000 transaction is not normal, right? So we looked at that. We said, this is not normal for this person. Is it terrorist activity, or is it just John Miko bought a home, right? So we had to do those kinds of things. So in the business world, you're always looking for, outliers. And we'll talk about this later in the class as well. So I'm going to close the chapter on histograms, if we can do that. Yes? Okay. All right, I'm going to cover some new material, and this is kind of chapter 2, and it's kind of not in your book, but I want to talk about it because it's important. There's no real work for us to do, but it is something that I want you to understand. Okay, so let's look at, in chapter 2, there's a set of slides that says, graphical deception. Okay, so if you think about it, when we started this class, guys, put down your laptop. You don't need it right now. We started this class. We talked about that statistics is a tool to get information from data, right? Statistics is a tool to get information from data. And like any tool, it can be used for good or bad, right? You can use a hammer to build a house or to kill someone, right? So what I want to talk to you about today is when we do graphs, we're striving for graphical excellence, which means we're trying to inform people with a picture, right? A concise picture. A picture is worth 1,000 words. We're trying to impart information clearly to people. But people don't always use graphs this way. There's a famous quote from Mark Twain. He said there's 3 types of lies. Lies, damn lies, and statistics. Because believe me, you can use statistics to mislead. And I want to show you some examples. Not so you can perpetrate the example, but so you can defend yourself against the example. So let's look at a couple. So here is an example. This says age dues revenue, in millions of dollars. And if you look from 1993 to 98, hell, it looks like, compare those bar sizes. Eric, what is the size of the 1993 bar or the size of the 1988 bar?
1993 one is significantly bigger.
Yeah, it's about twice the size, right? So that would lead you visually to believe that it went down by what? Half. But did it? No, it went from 60 to about 53, right? So why does it look like it went down by half? Why? Yes, Kyle.
Was it under? Like on the side where it's millions of dollars?
Yeah, on the y-axis. So we're using what we call a non-zero origin, right? So basically what we're saying is the first 50 don't matter. We're just topping off the top, and we're just seeing the difference there. If we did this same graph with a zero origin, this is what it looks like. Okay, there's definitely a downward trend, but it's not as exaggerated, yes? Okay, so who do you think uses this? Who do you think misleads with this kind of information? This happens all the time. There's examples. Here's one non-zero origin, sources of medical error with a zero origin, without a zero origin. What makes that effect look bigger? Who do you think misuses this kind of thing? Yes, JR. Where's it at? Yeah. Okay. Who? Sure. Advertisers really misuse this, yes? They say, like, this is going to, it's going to make you, you're going to lose weight or whatever, and they exaggerate the trends, right? An example that I found, and I see several examples, and hopefully this link still works. I didn't check it this morning. But this is for an additive for engines, which I know nothing about engines. But if we look, this is some kind of engine, something you put in your engine, and it's supposed to increase the compression of your cylinders, which obviously is a good thing. It's some kind of additive for your car. And it shows before restore. This is, I don't know what it costs, but this is before restore and after restore. So what's wrong with that graph? There's nothing wrong with the graph except what? Yeah, it looks like cylinder 2 went from, holy cow, is like 1/5 of what it is after I use restore. But really, it went from 65 to like 121, which is still impressive, I guess, but it's not actually real, okay? It's not actually what it's supposed to be. Advertisers use this. Political campaigns use this. It's sometimes you even see it in financial statements, which is illegal, right? Not only is it like deceptive, but if you try to mislead someone financially, it's fraud and you can go to jail, right? So it's very important that when you put together a picture like this or a graph, that you try to do it in a way where you're informing, not trying to mislead. Now, so a non-zero origin is one way to mislead. Now, it doesn't make sense to use a non-zero origin or a zero origin in things like this. Like this is the U.S. golf winning score for men and women since 1947. And if we use a zero origin, it kind of screws everything up. You can't see the difference. So this one, it's okay to use a non-zero origin, so we can really see the differences by year. Okay, but not always is it okay. What's wrong with this graph? Okay, it says company growth. And hey, things are growing, and it's using a zero origin, but what's wrong with that graph? Why is that deceptive? Company growth. What the hell's growing, Mr. Boyd? We don't know. Is that profit? Is that like work time deaths? We don't know what that is, right? Something is growing, but this isn't labeled, yes? So that's why it's so important to label company growth. It looks like things are good, but we can't tell because we don't know what it is, okay? So for maximum clarity, you should label points. That's why I'm a stickler for those kinds of things. We see sometimes uneven axis tricks, like 1997, 1996, 97 to 2000. Well, it looks like they're trying to hide data. What happened in 88 and 99? Okay, so you'll see people do these kinds of things. What is a leading question? Anyone a fan of like Law and Orders or have law inspirations? Anyone a good pre-law concentration here? All right, sorry, Tony. What's a leading question? Yeah, like, did you enjoy murdering that person, Tony, right? And that is leading us to the conclusion that you murdered the person. Yes or no only leads to the conclusion you murdered people. So we can do the same thing in graphs with titling, right? A dramatic title like Med School Applications Plunge. That's a leading title, right? We want the viewer to get the end, to make the conclusion. We want to say Med School Applications since 1997. If they want to say it's plunge, if they come up with the conclusion it's plunge, well, that's fine. But we don't want to lead them to that, right? Maybe not in the graph. We want to show the information and have them draw their own conclusions, right? You know what I'm saying? So this is a dramatic title using a non-zero origin. It's a rotated graph, so there's a lot of things wrong with this. Conclusions differ. This is is church membership slipping. That's a leading title. Well, yeah, it's slipping since 1970, but it's actually up since 1950. So, generally we want to use just a statement here, like church membership since 1950. Estimated data is a problem. If you're estimating data, you should clearly denote it like, hey, this fourth quarter results aren't in, this is estimated data, that needs special things. These are dramatic effects, like look at this damn thing bursting through the chart, right? That is also leading, like, hey, we can't even contain this thing in the chart, right? That is not something we want to do. It might get attention, but obscures the data. Generally speaking, some of you guys in your assignment did some nice 3D graphs, but generally speaking, we try to avoid them if we can, unless we can make it in such a way that it's not, it's easier to read. Look at this one. It looks like one of those eye tests, where you're optical illusion tests. Okay, so we try to avoid them. We also try to avoid chart junk or distracting pictures. Like, we have a thing here crying, because it's bad. That's a leading title, the leading thing. This, a lot of chart junk, a picture of a nurse, a big needle coming at you. I don't know what the hell's going on up there. But all those things are distracting and take away from the point of the graph. This last trick is probably the second most commonly one that you see is the area trick. So this is, I don't know what this graph is, but it's a bar chart, 1990 through 2000, and we're using a quarter instead of a bar. Well, when we make a picture higher, what do we also have to do to the picture? We have to widen it, right? So this quarter is twice as high as this quarter is twice as high as this quarter, but we also have to widen it. So we go from 2 times the area to 4 times, right? 2 times the height means 4 times the area. This quarter is actually 16 times the size of this one, even though the data it represents is only 4 times as high. So generally speaking, we want to avoid using pictures for graphical items, right? So we want to use bars, not bar charts. So here's another one of these. Area trick. This is someone who didn't even use a picture. They just made the bars thinner. You notice how the bar's thinner here. Non-zero origin, dramatic title. All these things can be done. So if you think about it, you've been given a tool here. You've been given the tool to create graphs, to express yourself, to talk about a situation in the workplace. And because we're all Franciscan, we're going to use this tool ethically and for good, not for bad, right? But I want you to know the ways we can use it for bad so that you can defend yourselves against those items. Now, a bonus point opportunity is if you can find a present example in advertising or political campaigns where they're using misleading statistics, graphical statistics, and you bring that into class, I will give you a bonus point or 2. Okay? Does that make sense? So it's out there and it's out there everywhere. All right. So all we'll talk about with that one, there'll be a couple multiple choice on the next exam. All right. So let's talk then about the next exam. The next exam, or the first exam, I guess, if you will be 25 multiple choice and 1 in-class Excel problem. Okay, 25 multiple choice and 1 in-class Excel problem. No hand problems because we haven't done anything back here. So first off, we can have that test Thursday or Tuesday. I don't care, because if we don't have it Thursday, we'll just go into chapter 3, and use class time that way. So it doesn't matter to me. I'd like to hear your. Why? All right. Wow, that was like the garbage can model. Oh, man. All right. Next Tuesday will be our first in-class exam. Okay, so before we get started in chapter 3, I want to show you guys out on Blackboard under sample exams. And you can bring up your laptops now. What I always do before any exam is I try to give you a sample exam, right? A sample is like a subset drawn from a population that represents that exam. And a lot of times they're old questions from previous exams so that you get a sense of what the exam will be like. So it's not like a big surprise, like, holy hell, what's this? You know, like, I want you to know going in what we're going to be doing. So if you see sample exam 1, Excel and multiple choice portion, this is going to be like the exam that we have on next Tuesday. And there's an old video from last year where I review it. But let's look at the sample test 1 multiple choice portion, because I want to give you a sense of what my multiple choice are like. Okay, so this exam will be on chapters 1 and 2, first and foremost. There'll be 25 multiple choice, and I have a sample of like 7 here, right? So from chapter 1, we try to understand the difference between statistics and parameters, populations and samples, confidence level, significance level, descriptive statistics, and inferential statistics. You guys remember that as the terminology in chapter 1. So if we look at the first one, a politician who is running for the office of governor of a state with 3 million registered voters commissions a survey. In the survey, 53.6% of the 5,000 registered voters interviewed said they plan to vote for him. What is the population of interest? Very good. It's 3 million, so the letter is A. What is 5,000? It is what, Mr. Boyd? It is the sample. Very good. Is 53.6% a parameter or a statistic? It is not. It is a statistic. Why is it a statistic? Because it goes with the sample, right? If going into this I said, I think I'm going to get 70% of the vote, that would be a parameter because it goes with the population. So there'll be 2 or 3 like this, right? So if you can identify those 2 things, that's great. Which of the following is not the goal of the descriptive statistics? So descriptive statistics, we summarize, we display aspects of collected data, we report numerical findings. What we don't do in descriptive statistics is estimate characteristics of the population. What branch of statistics does that? Not descriptive, but right. So your name's not AJ, but I don't know what you're called, right? So this doesn't answer it. So you gotta see. No. It's D is the answer. But what is D? I eliminated three answers for you. D is what kind of statistics? Descriptive versus inferential statistics, where we make an inference, right? We take a sample statistic, make an inference about a population parameter. Confidence level measures what? What do you think confidence level measures what? Confidence level measures what? Roger, what do you think? I'm going to pick on you, Roger. Confidence level is a proportion of time the necessary procedure will be correct in the long run. The one that says wrong in the long run is what? Confidence level was correct, what was wrong? You guys remember? Significance level. So those are just terms, right? Those are just terms in chapter 1. Read chapter 1 and understand that. I can't make you make graphs. Well, I can make you make graphs, but not in a multiple choice test. So what I do ask you, though, is I ask you to understand the types of data and the types of charts we use for that data. So if we have the best type of chart for comparing 2 sets of nominal categorical data, like gender and, I don't know, major, what chart do we use to compare 2 sets of nominal categorical data? So if this test for data, you got it feels that way. I've been teaching my butt off up here, so that's disappointing. But it would be a multiple bar chart, so D, a bar chart. The number of cars in a given parking lot is an example of what type of data. So we only have 3 types of data: interval, ordinal, nominal. So any other answer is BS. Optimal is BS. So it's interval, ordinal, or nominal. The number of cars in a parking lot. Down there's 48 cars. JFK, there's 212. Stokes, there's 86. That is interval data. It's real numbers. Very good. A set of 85 observations are gathered. The smallest observation is 500, and the largest observation is 900. using the supply chart. So I'd give you that little chart. It says what would be, what should be the class size, the class width. Well, if we think about it, if we have 85 observations, that says we should have between 7 and 9 classes, okay? Between 7 and 9 classes. And the width of this is 500 to 900 is 40 of 400. So if we divide 400 7, 8, or 9 ways, which of these makes sense? How wide should the classes be? So we got to cover from 400 to 900, which is 500, and we want to divide either 7, 8, or 9 ways. So you think 50 makes sense? I'd say 50 makes sense, right? What's that? Yeah, 500, 200 are too big, 10 is too small, 50 is about right. The histogram above can best be described as what? What about this histogram? So when we look at histogram, it's either positively skewed, negatively skewed. You can also look at the modality. Looks like I'm looking at the modality here. What would you say about this histogram? Unimodal or bimodal? I would say it's bimodal, so C is the correct answer. Although you won't have to do Excel on the multiple choice portion, I want you to be able to recall what Excel functions we use for various things. Which Excel function is used to tell you the number of categorical responses during the creating of a frequency distribution table? What do we use to count the number of observations for a frequency distribution table? What function do we use? Count if, right? Salary is what type of data? Remember, money is always what type of data? Interval. If I asked you the size of a drink, large, medium, small, is what type of data? Ordinal, because there's a category, there's a ranking to it. What is the function key to make a cell reference absolute in Excel? To make the dollar signs, what do we use? F4, very good. How about to put the cell in edit mode? What was the function key we used? F2, very good. We use pivot tables in Excel to count the number of observations across 2 nominal categories. This was called what? What do we call that table? We call it a cross tabulation table. Very good. You guys got better. Why'd you get better? Because it's more recent material, I guess. So those are 12, right? It's a sample. It's not the whole population. What I do often is a lot of times I have the same damn question, but I ask a different thing. Like the number 1 where I ask, what is the population of interest? You can have the same thing, but I ask, what is the sample? So, this is a sample of, what the actual multiple choice will be like. Any questions on that? You understand what you need to study for that and how the format will be. Very good. We'll also have one in-class Excel problem. And I think I'm going to give you one like this. Okay, and it's kind of one we did already. But let's do it together today, just so now you have a whole week to prepare for this, right? So so don't forget about it. Let's have a whole week to prepare for it. So this one kind of uses the one thing I didn't test in class, which is important, which is something I want you to understand, is how to do some basic things with a pivot table, right? So let's look at this one, sample exam Excel problem 1. It says sample cells, data 500 transactions, which we used before. We want to determine if there's a relationship between container and ship mode. Please perform a crosstab on these 2 fields using a pivot table. Place container on the rows, ship mode on the columns instead of counts. I want you to use a percentage of the row setting. So I'm telling you exactly how to make this one so we all have the same pivot table. So when I grade it, I'm like, okay, yes, 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 okay. Create a bar chart to represent the pivot table you created in step 1. Okay, so let's do this one first. So I'm going to bring up the data. It's already in the most recent version of Excel. And I'm going to highlight all my data. A to Z in this case. I'm going to go to Insert, Pivot Table, click OK, and it puts it in a new worksheet, and here's all my fields. So it says, please put container on the rows and ship mode on the columns. Okay, so let's do that. Container, I'm going to drag down the rows. Ship mode, I'm going to drag to the columns. I want to count something, so I'm going to count ship mode. You guys here? And I think I said I want you to use percentage of rows for the field settings. So how do we change the field settings for that count? 3 ways we can get there. Give me one way I can get there. I can right click on any value, go to value field settings. I can go up here under Analyze to Field Settings. I can click this drop down and go to Value Field Settings. I want to do Show Value as percentage of row total. I think in part 2, I asked you to create a pivot chart of that data, so I'm going to do a pivot chart. Click OK. I probably want to get rid of the blank. How can I get rid of the blank? I can use the drop down to filter out the blank. We did this one before. I could also pretty this up, and you guys know how to do that by now, so I'm not going to spend details on that. So that would be part 1 and 2. Okay, so I think we've done the hell out of that. The part that I don't recall us doing is part 3. Okay, so I'm asking you now to create another pivot table. So we're going to take that same data, create another pivot table that shows region on the rows and includes 2 value fields. A sum of sales, formatted as currency, with no decimal places, and an average sale formatted the same way. Okay, so follow along here. We want, by region, we want total sales for that region and the average sale amount for that region. I don't think we did that before. Okay, but it's simple, but follow along. I'm going to go back to my original data, still highlighted, so that's good. And I'm going to insert a new pivot table. And it says, do you want a new worksheet? Sure. So I still have my original data. I still have that old pivot table I made. And here's a new one. Okay, here's a new blank canvas. If you recall, it said I want sales by region. So I'm going to take region and drag it down the rows. There we see Central, East, South, and West are our 4 regions. And by region, I want to analyze, if you guys recall, sales, right? So instead of just counting something, I'm going to take a numeric value and I'm going to do a little bit more with it. So I'm going to take this sales value and I'm going to drag it to values. Okay, and it says count of sales. So it's telling me, this is one way to look at it, it's telling me I had 499 sales, 127 were here, 126, 57, and 189 were here. But I want the total amount of those sales. So instead of counting, what do you think I should do? Instead of counting the number of sales, what do you think I should do with those sales? Very good. I should sum that. So if I go to Value Field Settings, which I can do one of 3 ways, as you know, and I go to Value Field Settings, I'm going to change that to Sum. And I'm going to click OK. So now instead of counting the number of sales, okay, it is summing the sales. So now I can see that in the central region, our sales total was 86,000. East was 166,000. Now we have an issue here with this. That doesn't look like money to me. Does it look like money to you? It doesn't look like money. It looks like a number. Let's make it look like money. So I'm going to do that value field settings again. And where I changed it to sum, you see down the bottom corner, see that thing that says number format? Click on number format, and you'll see, all right, we can change it to, I'm going to change it to currency, I think is what I asked. And cents don't matter when we're talking about thousands of dollars. So I'm going to get rid of the decimal places. So I'm going to change it to currency and 0 decimal places. And now that looks like money to me. So now I can see that I had $437,000 in sales, of which 166,000 were in the east, 33,000 in the south, 150,000 in the west, so forth and so on. I also want to know what the average sale amount was in that region. Just is there higher value sales in some regions? So what I'm going to do is I'm going to drag sales again down to the values. And by default, it said count again. Okay? I know I could change that to sum, but I'm asking for the average sale amount. So I'm going to drop that, or hit that drop down, go to value field settings. I'm going to change that to average of sales. Once again, I forgot to change the number format, so I'm going to change that to currency and no decimal places. So it looks like, one of the reasons why our sales are higher in the east is it looks like our average sales are higher. Like we're selling more per sale in the east than anywhere else, almost twice as much as any other region. Okay. So now we have, and I could, obviously you guys know I can change the design of this to something that I'm more proud of. So, like that maybe. Okay, so now I have different information than I had before. So you'll have to do something like that, like a pivot table kind of exercise, where you create a crosstab and a pivot chart, and also something where you just analyze some data, like summarize some data. Yes? That is next Thursday. So 25 multiple choice, 1 in-class problem. Next Tuesday, I'm sorry. What is that? The 20th. That's my wife's birthday. I had to get on the phone. I fumbled the 20-year anniversary. So. You got to make up for it. Yeah, September 20th. So I'm trying to think if we need the whole class period for that exam. We'll see. All right, good? Good. All right, we're going to transition because we have 25 minutes left. To chapter 3. All right, so just to frame where we're at. We started chapter 1 by saying there's 2 branches of statistics. Which one you forgot about already? Inferential and descriptive, right? I said in STAT301 we focus on descriptive, describing, summarizing data. And I said there's a couple ways we do descriptive statistics. If we show it as a picture, as a graph, that's called graphical descriptive statistics. If we show it as a table, we call that tabular descriptive statistics. And the third type of statistic, descriptive statistics, is we show it as a number, numerical descriptive statistics. And we are going to, in this chapter, talk about God bless you, 4 categories that we're going to learn some descriptive measures in, numerical descriptive measures. First one, which we're going to cover today, is, I'm sorry, but it's so easy it might be offensive, right? Because this is something, it is kind of offensive in a college level class, but that's why we're going to cover it in like 10 minutes. We're going to talk about measures of central location. Like, how do we measure the center of a group of data? We're also going to talk about measures of variability, like the spread of data, how spread out it is. We're going to talk about relative standing, which is like percentiles, like Evan's height is in the 99th percentile. And we're going to talk about measures of linear relationship, which kind of dovetails nicely with that scatter diagram. We said, hey, that looks positive. Let's get a number that more precisely tells us exactly how strong that relationship is. Okay, so we are going to talk today about measures of central location. And the first one is so ridiculously easy that I caution bringing it up. But it's something that you know since you were probably in 3rd grade as the average, right? The arithmetic mean is known as the average. The average is simply computed by adding up all the observations and dividing by the number of observations. So if I wanted to average, say, the number of hours you guys slept on average last night, I would ask Sydney how many hours, I'd ask Kelly, I'd ask Eric, I'd add them all up and divide by 30. And now I have the measure of the central location, right? I have the one number, yes? Yes. So what's wrong? What's the drawback of the average? One of the things that's nice about it is we all understand average, right? We've seen it before our whole life. What's the one drawback with average as a measure of central location? Yes or no? Outlier. So if there's 10 homes in my neighborhood, okay, and let's say they all make, I don't know, about $100,000. So we add them up and say, $1 million divided by 10, the average income is $100,000, right? What happens if I move out and Mark Zuckerberg moves in? Now we take those 10 homes and add up the annual average income, and now it's $500 million divided by 10. And we're saying the average income of those 10 homes is $50 million. Well, that one value, think about it, Mark Zuckerberg is an outlier in income-wise, that skewed the mean. And it doesn't really represent all the homes because that one observation is huge and really stretched things, yes? So the arithmetic mean is subject or can be skewed by outliers. The notation we're going to use, which is important, which is something that may be new to you, is this is statistical notation. When we talk about the number of observations, and this goes across any disciplines, people will say, what's your N? Okay, what's your N? N means like, what is your sample size? Like, how many observations? So anytime we hear, what is your N? I have an N of 30. That means 30 people, 30 observations. We use lowercase n when we're talking about samples, and we use an uppercase n when we're talking about populations. Okay? The symbol we use in the world of statistics for mean, for arithmetic mean, is when we're talking about a population mean, we use mu. Okay? It looks like a cursive U. It's a Greek letter mu, which looks like that. And when we talk about a sample mean, we use something called x bar. It looks like an X with a bar above it, crazy enough. Okay? Those formulas look like this. So it takes something simple, but this is those things in statese, if you will, stat notation. If you look at the sample mean, what this is saying is the sample mean, x bar, is equal to all the observations, x sub I, and we've seen this symbol before. What does this symbol mean? What, Kelly, did you say something? It's sigma. What does it mean? Where have we seen this symbol before? You even saw it in Excel, maybe. When we clicked on, go ahead. It's the auto sum. It means sum up all the observations. So start at the first observation, go to the nth observation, and as we go through, sum them all up. Okay, so all this is saying is the same thing as this. Sum the observations, divided by the number of observations. That's just stat ease, right? So you have to understand that. That's the formula. So the next one is the median, okay? The median is also known as the middle observation. So the middle, the median on a road is the middle. The median is the middle observation. When we have an odd number, okay, that works out pretty easy because we put them in order. Like we have 9 observations. So we have 4 on this side, 4 on this side. Our median is 8, right? Because it's right in the middle. There's 4 on both sides. If we have an even number, well, it's not as easy. We've got to put them in order first. And we know we have 5 here, 5 here. We have 10 observations. It's halfway between 8 and 9. What's halfway between 8 and 9? 8.5. Here is a formula you can use if you want for the location of the median. N plus 1 divided by 2. So you put all of the values in order, and if there's 9 values, think about it. 9 plus 1 is 10. 10 divided by 2 is 5. 5 is not the median, but if I go to the 5th observation, 1, 2, 3, 4, 5, that's the median, right? In this case, there's 10 observations. 10 plus 1 is 11. 11 divided by 2 is 5.5. The location of the median is observation 5.5. So 1, 2, 3, 4, 5. Halfway between 5 and 6, halfway between 8 and 9 is 8.5. Does that make sense? One thing do not forget to do when you figure out the median is to put them in order, right? Put them in order first. Put them in ascending order. The third one, thing that we're going to talk about in this area is the mode. Okay? The mode is a value that occurs the most frequently. So if we look at this set of data, the mode is 0 because it occurs twice. Everything else occurs once. So the mode is the thing that occurs the most frequently. We can have 2 modes, we can have 3 modes, we can have no modes, right? So if everything occurs once, we have no mode. If everything occurs 2 times, I guess they're all modes. Whatever occurs the most frequently is called the mode. So a couple things. I forgot to tell you this, but the median susceptible to outliers like the mean is. If this last observation were, instead of 22, it was 22 billion, would the median change? No. The middle observation is still 8. So the median isn't susceptible to outliers. That's a strength, but also a weakness, right? Now we just took a value and multiplied by 1 billion and it didn't change. That doesn't seem right. The mean would change. So oftentimes what you'll see is places report the median and the mean, right? Because you want the whole damn picture, right? You want to see, oh, the mean's real high, but the median's the same. That must mean I have an outlier. Okay, so you need to understand how those things work together. So, a couple things. I want to show you how to do this with Excel, but before we do that, I want to show you. I want you guys to do one by hand. So I would like you to do. I'm just going to do one. All right, so take those observations on the board and figure out the mean, median, mode. That's 13, yep.
Yeah, but
Who's that? Yeah, John.
you count 0.
Yep, it's an observation. All right, so here's our observations. There are 8, so n is equal to 8. Get the mean, we add them all up, divide by how many there are, mean is 5. Yes? Yes. The median, well, there's 8 observations, so the location of the median is 8 plus 1 divided by 2. Location of the median is 4.5. That's not the median, that's the location of the median. It's a location formula. 1, 2, 3, 4. Halfway between 4 and 6. What lives halfway between 4 and 6? 4, 5, right. The mode is 6 in this case because there's 2 of them, right? So pretty simple? Yes, pretty simple. Let's go and do this with Excel. So I'm going to just go into Excel, open a blank workbook, and I'm just going to type this data in. So all I did was type those 8 observations. Every observation goes in its own cell. So obviously Excel provides functions for these things, and average, the function is called average. So we're going to average A2 to A9. And it does that work for us and comes back with 5. Median is called equal median. Crazy enough. A2 to A9. What? Oh yeah, that's right. and mode is equal mode. So the three formulas we're using there are average, median, and mode. Pretty simple, yes? And what's nice about that is if there would have been 1,000 numbers, by doing this by hand would have taken me considerably a lot of time and I probably would have screwed it up. Excel, it would have been the same operation. Instead of A2 to A9, I'd go to A2 to A1001, and I would have done it just as fast. Now, if I want to do all of these things at once, and oftentimes I want to do all of these things at once, what I can do is if I go over here to the data analysis, remember where we did histogram? There is an option that says descriptive statistics. I would like you to go to that option, descriptive statistics. So data analysis, instead of histogram, go to descriptive statistics. And click OK. My input range is A1 through A9. It's organized in columns, right? It's in one column, so I'm going to leave the columns option button checked. There were labels in the first row, so I need to tell it to ignore the labels, and that's why I checked that box. I want my results in a new worksheet ply, and I want summary statistics. So I'm going to click on summary statistics.
I click on data and I see it.
Do you know? Well, 1 second, JR. We'll turn it on for you in a second here. I'm going to click OK, and it builds a table in a new worksheet. It gives me many things, and among those many things it gives me is a mean. I'll shake that. That's awful. Too much coffee. The median. Wow. And the mode. Okay, so it gives us those three things. So you need to know the functions because sometimes you have a bunch of data and you want to do the average for like 10 or 15 columns and you want it to show right below the columns. So you use the function. Sometimes you just have one column of data and you want to analyze the hell of that, you use descriptive statistics. So it's good to know both of these tools, right? Because there's times when you use the screwdriver, there's times when you use the hammer, yes? So it's good to know both of those tools. Did anyone else not have data analysis like JR? So the way I turned that on is I did File, Options, Add-ins. I click Go, and then we check these Analysis Toolpack buttons. Checkbox and click OK, and that'll turn it on. You should only have to do that once. So I don't know, I think you were traveling, Gabby, so you missed it. And Jared, were you not in class Thursday? You were here? Okay. So did you turn it on? Okay. So you should only have to do it once. All right, so what I'd like you to do for homework, you have a take-home assignment due Thursday, right? Yeah? It's out there on Blackboard. That is going to be printed. It doesn't have to be printed in color, stapled together. If you don't have a stapler, I'll bring a stapler to class. But don't dog-ear that damn thing and think it's going to stay together because it won't. So staple together. Bring it to class. I'll grade those. That's due Thursday. Plus, I would like you to do measures of central location 1 and 2 by hand, and 3 and 5 with Excel. Our first exam is Tuesday, a week from today. Evan, go ahead.
You said you want those.
They don't have to be in color. 'Cause I know you don't have access to color printers. So they don't have to be in color, no. But make sure you label things correctly, right? Label things correctly. Put in narrative, like a sentence or two after each problem to tell me what the hell this graph shows you. If you need help with that, come and see me or see a classmate. I want you to do well on this. This is a take-home. You showing me you can do what I've taught you to do.
Next time you